Hello, today's notes are 3.2, slope of a line. So the slope is the rise over the run. I know you've heard that somewhere in your past. So rise over run is the slope. Sometimes you might see it as the change in y over the change in x. It's always abbreviated m. All right, so find the slope from a graph. So if I'm looking at, let me get a better color here. If I'm looking at the first one here, the slope is -3 over 2, and it's going downhill, so that's why it has to be -3, so it goes down 3 over 2 for the slope, so I'm going to put m equals. The next one, the slope looks like it's going up 2 over 1, 2, 3, 4. So the slope of this line is up 2 over 4, and reduce that to 1 over 2. So what that means is I could have gone from here 1 over 2, would have been the same thing, 1 over 2. All right, the official formula for slope is this. So m equals y2 minus y1 over x2 minus x1. So let's use that formula for this. So finding the slope from coordinates through 2, 5, and 6, 3. So this is, I'm going to rewrite this. Let's think of this as the x1, y1. And it really doesn't matter the order here, but we're just going to go in this order. So this is x1 and y1, and this is x2 and y2. So using the formula for slope, you put m equals y2 minus y1. Write that formula again. Over x2 minus x1. So y2 is 3 minus 5 over 6 minus 2. So -2 divided by 4, which is -1/2. All right, letter B. And then let's look at a picture of that. So 2, 5 would be over 2, up 5. Over 6, up 3. You can see the picture, and it is a negative slope, so that should at least verify our negative is correct. So let's do the next one, m equals, and let's make this x1, y1, and x2, y2. So y2, -1 minus 3 over x2, -5 minus -2. So -1 minus 3 we know is -4 over, this becomes -5 plus 2. So you get -4 over -3. And using your knowledge of negatives, negative over negative, so that's positive 4/3. Let's verify with the graph of that one, make sure it is positive. So I go back 2, up 3. I go back 5. Down 1. And I can see this is a positive slope. All right, the next one we have just some x's and y's, and so just choose 2 of the points on each of those, and I'm going to choose, why not just the top 2 here. So if I want to find the slope between those, let's make this x1, let's make this x2, let's make this y1 and y2. So m would be y2 minus y1, so 4 minus 3 over -2 minus 3. So it looks like I get 1 over -5. Does it matter which 2 points I choose? No. Let's choose 2 other points. So let's choose this one and that one. So the second set of 2, we should get the same slope. Using the green line now. Now we have y2 minus y1, so it's going to change those. So now this is y1 and this is y2. Changes this to x1 and this changes it to x2. So y2 minus y1 would be 5 minus 4 over x2, -7 minus -2. So 1 over -7 plus 2 we still get negative 1 over 5. So it doesn't matter which points that I choose. And then the next one would be, you can get this, you can work this out one on your own. Because I'm out of space here. But we're good. I think we've got that down. All right, let's look at slope for horizontal and vertical lines. So let's just do the formula. So m equals y2 minus y1. So 2 minus 2 over x2 minus x1, 4 minus negative 3. So I get 0 over 7, or 0. And that makes sense because the rise of this rise is none, and the run then would be your 7. No matter what you divide by, 0 divided by anything is 0. Look at the next one here, and slope is y2 minus y1, so negative 4 minus 2 over 1 minus 1. So that's negative 6 over 0. We can't do that, so that's considered undefined slope. So vertical lines, so you're doing rise over run. So from here, if I rise as much as I want. Let's go 6. But my run would be 0, so no matter how I look at this line, I get undefined slope. So vertical lines are undefined. Horizontal lines have a slope of 0. All right, so what we need to know now, parallel lines. I know you've heard this in the past too. Parallel lines have the same slopes. The same. Here. So parallel lines have same slopes. And perpendicular lines, their slopes are called negative reciprocal slopes. Example, if I say first slope is negative 5, the perpendicular slope in perpendicular would be 1/5 positive. So let's look at these then. So if I have a slope, original slope of negative 3, the perpendicular slope, think of that as negative 3 over 1, so you flip it 1/3 and change the sign. 3/5, the perpendicular slope would become negative 5/3. Negative 1/5, the perpendicular slope, you flip it and you get 5 over 1 and it becomes positive, so just positive 5. 0.1, you can think of it and know that that's 1 over 10. So when you flip that, you get 10 over 1 or 10. Or you could think of this as 1 divided by 0.1, use your calculator, and you also get 10. So no matter what, but it also needs to be negative 10. Right? Flip the sign, find the reciprocal and take the opposite sign. All right, let's look at interpreting slope here. Worldwide carbon dioxide CO2 emissions have increased from 14.7 billion tons in 1970 to 26 billion tons in 2000. Find and interpret the slope in figure 3.18. Well, we don't have a picture. So we're going to find the slope, find slope. So we're going to say 1970 has 14 billion tons. And in 2000, we have 26 billion. So what I want to do is we can make life a little simpler. Let's let 1970 be year 0. So we can write this point as 0, 14. Then this point would be 30 years past 1970, or 30, 26. And just knowing that our answers are in billion. So to find the slope m, y2 minus y1, so you take 26 minus 14 and realize those are in billions. Over 30 minus 0, so 26 minus 14 is 12 divided by 30. We take 12 divided by 30. 0.4 billion per billion tons per year CO2 emissions. And that would be increasing. So if it wants to know the slopes in 2010, we're increasing by 0.4 billion a year. This is year 2000. So year 2000 to year 2010 is 10 years. So you're just going to take your 0.4 billion per year times 10 years. So 0.4 times 10 will be 4 billion. What do we have here? 4 billion, let's label it right, tons in 2010.